I understand the efforts required. So thank you for coming. Okay, let's get started. So Ruby internals is the topic that I will be talking about, a visual walkthrough. That's my Twitter handle, RTDP. And that's a little bit about me. So there was a time when I used to travel a lot and come with the pictures and show something in the conferences. Not anymore. I'm not a digital nomad anymore. I got married. But the travel is something that I like. I run a company called BetaCraft Technologies. We do everything Ruby, everything JavaScript, and we try to work on things with a craftsmanship spirit. That's why it's a beta craft. I also like mechanical keyboards. I have a collection of them. So any of this interests you, come talk with me. We will have amazing discussions. Okay? Yeah. So I really like listening to the conference talks. And what I have found is when it comes to some of the latest information about the technology, I really get that from the conference talks. Sometimes some deep knowledge about certain part that you're struggling with is also available in the conference talks. And I recommend conference talks to my team members also. But I found that the discovery of the conference talks is not easy. So this is why I created this website called as Tech Talks. It's been created in like past month itself by my team. So it's still under beta, but here is the first time that I'm opening this up to everyone. So this is how it looks. You can go there, you can search talks that are trending, popular. You can look at the talks by the speakers and watch them, and mainly add the notes also there, which is useful. Yeah. I have some stickers, BetaCraft stickers and Tech Talk stickers. You can find any BetaCraft members to get the stickers or come to me and I will share them with you. Now, reading Ruby, a visual walkthrough. Yeah. So that's the topic that we will be talking about. So what I will be doing in this talk is first setting some context, like what this talk is going to be about. Next, I will be doing what and where. What I mean by that is we will be looking at what it takes to read the Ruby, where the code exists, what would be the good approach to get started. And in the process, I will also try to convince you that it's easier than it seems to be reading the Ruby code. Okay. Next is how Ruby works. That's not what this talk will cover, because if you get into that, it's a very complex. Each component of Ruby can have its own talk. So you must have seen yesterday's garbage collection related talk that was given by Puneet, or metaprogramming talk that was given by Chaitali. Those are the components, and you can invest your time. You should invest your time in understanding more about those. The good book that I always recommend for that is Ruby Under Microscope, nothing like it. Okay. And then to end this talk, I will also be talking about how to read code faster with the AI tools. Yeah. Yeah. So the next thing that we should all be talking a little about before getting started is why read code in the first place. So how many of you do code reading for any of the open source gems, any libraries, Rails, or anything, just to read the code? Okay. I see certain hands. Yeah. So the reason why that is important and essential is because we are into a field like if you look at how the craftsmanship culture is, where there is a craftsman and there is an apprentice. The apprentice learn from looking at how the craftsmen do their work and learn from it, right? It's not a theoretical book knowledge that you read it everything and then be able to be productive, right? Same thing applies to the software also, that you are in various companies working with some senior engineers when you are juniors and then learn from your seniors how to write the code. But the thing is, sometimes you might not have seniors or mentors to guide you in your companies, or other times those seniors are so much forced by the deadlines and the commitments of the production timelines that they don't have enough time to write the code the way they would like, right? And that's where reading the code that is open source comes in handy, because then you have all the mentors from the worldwide from which you can learn. And that's why reading the code from the open source gems is really, really essential, okay? Now coming to the next part, Ruby, like what programming language it's written in. So how many of you think Ruby is written in C language? Okay, how many of you think, or any guesses from any others, like what other languages could be there? Okay. So I was thinking about some of these questions yesterday, that I will be asking these questions and asking all the people that are here to raise their hands. And just like it's happening, there will be lesser hands than I would expect. And I was not able to sleep. We are in Jaipur, and I was thinking, oh, there is a company called as the Jaipur Food, which is very, very popular. I don't know if anyone know about that. Does anyone know Jaipur Food? Have you heard of this term? Yeah, so it's a non-profit organization based out of Jaipur. What they do is they make the food if you don't have one, and it is very, very cheap, like close to 100x cheaper compared to the other traditional options. And that's why it's very popular within India and rest of the underdevelopment places. But the point is, they also have Jaipur hands, okay? So, yeah, I was thinking about that, and yeah, this came up. Okay, so coming back to our topic, what we have is how many lines of a code is there in Ruby code base, which is written in different programming languages. So there are some build tools that are written in Python and Java and other things, but let's not get into that. We will just focus on some of the important ones, which is like a C and Ruby. And this is the numbers that I could gather from Ruby 1.3. This is done using a gem called as a clock. It's a tool, not a gem. It's a tool called a clock. Using that, you can get the lines of code from any of the files that you have available. So as you can see, at the 1.3, the C code is close to 51,000 and Ruby code is about 17,000. And then this is how it changed in Ruby 1.9.3, where the Ruby code is 5,25,000 and the C code is 2,28,000. And then when we come to the Ruby 3.3, this is how it changed. So C code even got lesser and lesser, and the Ruby code got higher and higher. And this picture that we are currently looking at, this alone doesn't tell the entire story either, because when it comes to Ruby 3.3, here is how it looks. There is a C, there is a Ruby, and then there is a Rust. About 22,000 lines of a code is in Rust. And that code comes from the recent implementations of widget, which was done by Shopify. It was a 3-4 month project wherein they ported the entire widget that was written in C and rewrote that into the Rust. And if you're using 3.3, then you are using a Ruby that had some Rust contribution into it as well. Okay. Now the purpose and the reasoning behind that was to begin with, like the most important was the complexity management. So when it comes to the C, which is the C90 code base and standard that is being used, it's very hard to manage the complexity within the code base. Specifically for very complex applications like the widget, it was getting even more complex, and the maintainability and the bug fixing was getting out of the hand. And that's when the Rust came in, because it completely came into the picture to solve the exact issues that they were looking to solve. In the references, I will also be attaching the links to the various blogs, and one of the blog is from the Shopify itself, talking about what exactly was the purpose and what were the nuances that they encountered into it. Okay. Now, why Ruby to write Ruby? Like, as we were seeing over the years, the Ruby percentage of the code in the Ruby source code itself is growing, while the C is going down. And the reason for that is productivity, handling complexity and maintainability, right? Ruby is, as we all know, is very easy to handle, easy to read, easy to understand, easy to maintain. And the complexity, if it is higher, you have a multiple options to represent that complexity in object-oriented space much better, which is very harder to do that in the C. And then next is a performance. Of course, C is a faster, but then it is mostly faster. Like there are certain cases wherein Ruby would be faster compared to the C. So I will also be adding a reference talk in this, like at the end of the references, where Koichi speaks about what are the areas where it makes sense to have it written in Ruby and still be faster compared to having that older implementation in the C. Okay. And then the last reason for that is annotations or the API change context. So in some cases, what happens is if you're upgrading the Ruby that fast and your C code is very old and not upgrading as faster, that becomes the bottleneck when the API changes. Okay. So, and then the next slide that I have is why Ruby to write the Ruby. Okay. And in that sense, when it makes reasonable sense to write the code in the Ruby versus when it makes reasonable sense to write the code in the C. First one being the performance needs, that if a part of the code is frequently being used, of course it makes to go into the C. Then easy, like whether it's a very complex code base or whether it's a very easy. So if it's easy, makes sense to just write it in the C. But then if it's very complex, then from the long-term perspective, maintainability perspective, it's better to move that into the Ruby. Yeah? And then there are certain stuff that just can't be done in Ruby. So we will never have a future where it's all written in Ruby. It has to be some C to make it work. Yeah. And this is the graph that I have, wherein it shows the percentage of Ruby code and the percentage of C code over the multiple Ruby versions. So what we have here is Ruby 1.3, where 75, close to 75% of the code was in C and just 25% in the Ruby. And over the years, with the 3.3, we have just 22% in C, while 77% in Ruby. So almost complete switch. Now the numbers for 3.3 don't add up to 100, and the reason for that is there is also a Rust code that is not included in here. Yeah. Yeah. Okay. So, like the first time I started reading about the Ruby and the Ruby source code was when I was building this Ruby Vernac that Gautam just mentioned. That I was trying to write the code so that you can program in your own languages. So here is a Hindi code, which is the actual working code, where I have a Sancha Gabbar, which is a class Gabbar, and then a Khalnayak is a variable that is instantiated as Gabbar.naya. In hindsight, I would have done it as a Gabbar equal to Khalnayak.naya, but then, yeah, it's okay. And then the second example is where it's a Ruby Vernac emoji, where you can write the entire code in just the emojis. So all of that you see here is again a working Ruby code. But while building that, I went through the Ruby code base, and that has resulted into this particular talk. Yeah. But it was not easy to do all the code reading there, because I remember thinking that going into the Ruby is all C, and I don't understand C, or I'm not as proficient into C. And then they are writing a language in C, which is such a complex thing in itself, right? And that is written with a C. So I don't know, I'm not able to read it or things like that. But this is the number, like I just ran some scripts to check how many file extensions are there in the Ruby source code. And there are about 123 extensions that are present. The main ones that we need to look at is the C and .rb files. But then there is so much to ignore and so little to focus on. So that's one of the challenges when it comes to reading the source code, that apart from deciding what to read, you also decide what to ignore, because there is so much to ignore. There are build tools, and there are hundreds of things that are happening, housekeeping that's happening. Yeah. Okay. So that brings us to the next part, which is if that's the case, then what is the easiest place to start? Yeah. So I would say, think of it like this, where the step one should be the standard library. I should also mention that when it comes to the numbers that we looked, or all the graphs that we looked at, what was also happening was the standard library was included in those calculations, and because of that, the standard library has grown over the years from Ruby 1.3 to Ruby 3.3. So that has some contributions into increasing the numbers and the percentage of Ruby that is present in the Ruby itself. But that is the best place to start reading the code also. Like start with the standard library. You have all those standard gems that you can go to and read the code there, and those get included when the Ruby is being built. Then the next is pure Ruby core components. So there are certain core components which are written in pure Ruby. There are no C parts to it. Majority of those are related to the housekeeping, automation of the scripts and everything. But that is also another place where you can come from the Ruby background and be able to read what's happening. The next is Ruby with the C extension. So there are lots of standard libraries also and core components also, where the part, like some part is with the Ruby and then some part is kept with the C using the extensions. So that could be the third step. And then the fourth step is core components that are completely written in C and have a very complex logic, like a garbage collector and all of those. So when it comes to practicality, I would suggest the better option when it comes to reading the code and experimenting with it is starting with the mini Ruby. So what mini Ruby is a very short or a small version of the entire Ruby source code. It is actually required to build the Ruby. So when you take the Ruby source code and you're trying to build the Ruby, what happens is one of the steps is to build the mini Ruby first, and then there are commands to build the entire Ruby. And the reason it is being done that way is because this mini Ruby is required for running some of the Ruby scripts which are required to build the Ruby itself. So having this mini Ruby saves you from that circular loop of having the dependencies. So for example, here is how the traditional build would require it to happen. That there you have a working Ruby on your machine, which you need to run, which will do the configurations, which will do the build, and then it will do the installation. But then if you don't have any Ruby installed and running on your local, then you don't have an option. But then that problem gets solved with the mini Ruby build. With the mini Ruby build, what happens is with the C compiler itself, you get the mini Ruby, and then that mini Ruby is used for doing the configuration, build, and install. So that way your circular dependency gets resolved. And this concept of writing a lot of code in the Ruby itself for the Ruby programming language is called as a self-hosting. Yeah? So the mini Ruby is an essential component in getting to that self-hosting phase. So now these are some of the two commands that I ran to just get an idea about how much objects get initiated when you start a Ruby versus a mini Ruby program. So for example, the total objects, if you are running Ruby, it's 25,677, but with the mini Ruby, it's just 10,000. So if you are trying to get into the Ruby, what I would recommend is start looking into the mini Ruby, try writing some code samples and examples just with the mini Ruby and execute them, and then see how it works. Yeah. So that is about experimenting with Ruby. Next is the part that we discussed, which was the core components that are written in the C. So how can I start reading that code? And this is where it becomes easier, because a lot of test cases that are required for reading that are actually written in Ruby, and that's the best place to start. So for example, here we have method.rb, so VM method.c or source/method.c. These are the places where there is a lot of C code, like there are some C files that run into thousands of lines also. If you directly go there and try reading that C file, it gets harder. But then if you start with these Ruby test cases, it will get easier and faster. So with that, we come to the last part of the talk, which is how to read code better with the AI tools. Yeah. So when it comes to the conceptualization of this idea, I look at it from this angle, that the classical approach is bottom to top. So imagine that your code base is kind of a tree where each file is a leaf. So you start with reading some of the files, and then based on that, you keep those in your head, and then you read some other files. Let's assume that your folders are branches, and then your entire project is a trunk. So to get that complete tree understanding of the entire project, you have to complete a lot of leaves, then start with the branches, and then come to the trunk. And it takes a lot of time. It requires you to build those mental pictures in your head until you get that complete picture ready in your head, right? And that's where with the AI, it becomes a different type of approach, where you go from the top to bottom. So what you can do is you use these LLM tools to rather summarize the things for you, and you start reading the summary first. So imagine you are building your mental model of a trunk first for any code base, then you are building the mental models for the various branches, and then you actually go into the files and then start reading the code, because those are the leaves where you get the exact accurate details. Now coming to the next part, like when it comes to the Gen AI and the LLMs, it's commonly used use cases for generating the new code or generating the content. But if you think about it, the other side is equally or even more exciting, which is the summarization of the contents. And it's not given much of a emphasis. So I feel like that's a very essential idea that we should also look at. So one of the tools that I highly recommend is Cursor. There are two examples that I have given. So for example, there is this file called as gc.h, and I have asked it to summarize the code in that file. And it has provided me with like a couple of lines of summary. So with that summary in mind, I can go and see if it matches what it's saying. And then the other example is in that same file, I told it to add the comments for each line, explaining that in the detail, because I'm not well versed with the C. So it tells me, okay, what this file is doing, what that file is doing, what this file is doing. Sorry, line by line, what this line is doing, what that line is doing, right? So that is one of the way to read the code. The other way is this tool, which is the Notebook LM, which is the Google tool that uses the Gemini in the backend. With this, what you can do is, one of the gems that I recommend people to read when it comes to good gems to read the code from for the Ruby is a gem called a Shrine, because I find that it is very modular and built very nicely. The documentation is very clear. So if you are going into the code reading side, one of the first gems to read is this one, Shrine. So what I did was I wrote a simple script. It looked at the lib directory of that gem, pulled out all the code, put it into a single file with adding the comments that, okay, below code is from this file, this file, this file. And then I used that as a text file. I uploaded it here. You see combine.txt. And then I just asked Shine to summarize it for me. And now it has summarized everything, like what are the classes there and what they are doing and whatnot. So this is another way to start from that trunk. You get the overall idea and then get into it. And it's 100% the case that it is not correct in the sense that there are some inaccuracies that could be present. But the most important thing to remember here is, I was told by this incident by one of my friends, where what happened was, he was explaining how to use the ChatGPT and similar tools to one of his colleagues or juniors. And then next day he got an email asking for the leave, which was an email generated with the ChatGPT. And then this was the first line. Yeah, dear insert manager name here. So being lazy is not the purpose here, but being smart and curious is the purpose. So we will stop with this, like tips on using LLMs. First, context, ensure relevant code is being looked at. So it's very easy for you asking certain questions to the LLM, and it is looking at a different version of the Ruby compared to the version that you want to understand or get the answers for. So super important that the context is clear when you are asking these questions. I have seen in my experience that when it comes to the super duper high quality models like GPT O1 preview gives wrong answers or incorrect answers compared to a less powerful model which has a correct context. So even before the models, the context is important. When it comes to models, see what works best for the job at hand. Like there are multiple options. Next is prompt engineering. It's an essential skill. It can only do enough based on how much you can explain correctly what is required. So treat these tools as your juniors or the interns, and the interns are only as good as the instructions that you provide to them. And final ingredient is the curiosity. So you must have had those relatives kid who keep on coming with questions after questions after questions, and it gets irritating. That curiosity is what would help you here, because every output that is given by the LLM can't be trusted. So if you're looking for a certain information and it is given by the LLM to you, you need to ask 5 different questions and ensure that it is falling in the line. And even after that, look at the exact code to ensure that, okay, it is what it is saying. So only the curiosity can help you in that sense. Okay, finally the conclusion that I would like all of you to conclude after this talk is, it's very easy to look at the Ruby source code. Have a look, and there are some resources, and I have stickers. Thank you.
So that you could like build that emoji vernacular. Yeah, that's the questions.
Yeah, so the very first version of the Ruby vernac that I had built required some changes into the C code, specifically related to the numbers, because it was not possible to translate the numbers in the local languages and then be understood by the Ruby itself. So that part, for that part, I had to change the Ruby and recompile it, and then anyone who want to use Ruby vernac had to use that recompiled Ruby version itself to make it work. But the latest versions that I have, which are also hosted on the Betacraft repository, they don't need that, because now there is a kind of a transpiler who sits in front of the Ruby and changes everything before it even hits the interpreter. So the code that I showed, the 2 samples, in the latest version of Ruby vernac, they don't need any changes in the code.
Awesome.
How interesting that you're reading Ruby internals, but the question comes at Ruby vernac slider.
Hey, since Ruby is an interpreted language, the C code has to compile to an interpreter, right? So that's a compile thing. So the statistics that is show that the Ruby code is being increasing. So the interpreter has to be compiled. So Ruby code can't be compiled into thing, right? So the possible reason for the Ruby code increase is maybe tests are being increased on Ruby side, or maybe like the core thing still has to be in C, right?
Yeah.
And the Ruby file increase would be like subsequent things, but that is not core to the language. Maybe is that might be the reason.
Yeah, so the main Ruby source code is in the compiled format itself. The parts that are core to the C, but also are present in the Ruby, what's happening with them is there are some ideas that are being used in a sense that, let's say, if it's a string as a function class, and then you have a string like one of the methods into it, let's say capitalized, then the part of it is done in a Ruby and then part is delegated to the C extension. So that way the performance and execution speed is something that gets managed. But sorry, I don't understand. Is that the question that you're asking?
Yeah, kind of in the similar manner, because the core thing still has to be in C.
Yes.
So I don't see why the increment in the Ruby code might be like core to the functionality. Maybe that's like
Right.
subsequent things, right? I would say.
Right, absolutely. And what I feel is one of like what could be very interesting to see is how these numbers change if I take out the standard library out of it, because the standard library has also grown with the time, and that is contributing a little in terms of how much the percentages are changed there. It seems to be like a lot of Ruby is being written, but how come we still having to use the C, right? It's like that, yeah.